ल केटाकेटी हो एउटा प्र्याक्टिस टेस्ट गरिदिउँ है त यसमा चाहिँ नि अब I'm not sure if this is going to be a one sample t test or a Wilcox test, but we'll find out है त just click on the practice test. Okay, so let me just read out the question first. It says a supplier of bottled mineral water claims that his supply of water has an average sodium content of 36.3 milligrams per liter. The box plot below is of the sodium content level that has been taken from a random sample of 15 bottles. With this data, investigate the claims using SPSS to apply the appropriate tests. So judging by the box plot, we can see that it is massively skewed. Like the median is way up there. So this looks like data that is quite highly negatively skewed, but we'll figure it out. So the first step is to download the data. So you just click on this little icon. The data should download. You can just open it up into your Excel. So I have it out here. So I'm just gonna like minimize it there. All right. So what I'm gonna do is I'm just gonna copy all of the data here, including the first row. So Control C, right? And then I'm gonna go into my SPSS, which is out there. So I'm going to make sure to paste this with variable names. All right, I'm not going to paste it. I'm going to paste it with variable names. So make sure you do this correctly. Now you can import it directly if you want through SPSS or whatever floats your boat. I mean, as long as you do it correctly, if you're confident with whatever you do, I mean, just go for it. You don't have to do exactly what I do, but this is just the preference or my preference. So one thing that I would suggest you to do, you don't have to do this, but the one thing that I would recommend is that once you've done this part, I want you to go to the variable view and then make sure you reduce the number of decimals to 1. In that way, you don't have to round it up yourself. That might save you some time. This is not a step that is mandatory, but I would recommend it because that would be easier for you to, so generally there'll be a less chance of you making a mistake. Okay, so now that the decimals are only in, let's say, in 1 decimal place, this should give you more accurate results. So, okay, let me just delete this. This is not necessary. I don't know. Okay, so once that's done, so we have 15 data points. So it says, check that your data transfer has been successful by obtaining the standard error of the mean for your data, which should appear in the SPSS output as 0.0480. All right, so to verify this, you can just go to Analyze, Descriptive Statistics, right? Explore. Under the Explore menu, make sure you copy the variable into your dependent list. Go into Plots. You do not need a stem and leaf. Make sure you check histograms, and then make sure you check normality plots with test. It's actually selected in my SPSS because I've just recently done this test. So generally this is not going to be selected for most of you. So make sure that is checked before you run the test. So click OK. The output window should appear, right? It should look something like this. Now, as we can see, the value here for the standard error is 0.0480, which is exactly what the question has asked us to verify, so it's correct. All right. So now that we know that we have the correct state of data, we can proceed with the rest of the questions. So the first question here is asking us to figure out or to write down the mean and the median. So the mean in this case, simple, it's just given right there. So the mean is 36.720. So make sure you put the 0 at the end, right? So make sure you put 36.720. If you just put 36.72, I'm not sure, but there's a chance that the test might call this a wrong answer. So make sure it's 3 decimal places. You put 720. Just you don't want to take any chances in this case, right? The confidence interval is given right there, 36.617 and 36.823. So that would be 36.617 and 36.823. So now the next question is, based on the 95% confidence interval, is it plausible that the average sodium content is 36.6 milligrams per liter? Now let's see what the confidence interval is. The confidence interval is between 36.617 and 36.823. So since 36.6 does not lie within the 95% confidence interval, what this means in, let's say, in statistical, let's say the analysis of this is that assuming that the as in from the sample we can derive that there is a 95% chance that the mean of the population from which these samples were derived is going to be between 36.617 and 36.823, which means that since 36.6 does not lie within this particular range, the 36.6 is probably not the mean of the population, right? So in this case, since this does not lie within this range, we're expecting that the average sodium content, which is supposed to be between these two confidence intervals, is going to be higher than 36.6. Therefore, the answer in this case is going to be no. The average sodium content appears to be a higher value than 36.6, right? The median here is 36.800. 36.800. Make sure you put in the double zeros after that. So the value of 36.8 generally is higher than 36.6. You shouldn't get that one wrong. Now let's look at the skewness. So complete the following concerning the skewness of the data. The skewness statistics in this case is negative 0.643. So the skewness statistic is negative 0.643. The standard error in this case is 0.580. All right. So the absolute value of the skewness statistic, which is 0.643, is that less than 2 times 0.580? So 2 times 0.580 would be 1.160, right? So in this case, 2 times the standard error is actually greater than your skewness statistic, which means that the absolute value of the skewness is less than 2 times the standard error, which forces us to conclude that therefore the data can be considered to come from a population that is symmetric, right? So if we had a situation where 2 times the standard error was less than the skewness statistic, then you would assume the data was either positively or negatively skewed, and that you would determine using the sign here, the sign of the coefficient. So in this case, since the standard error is times 2 is more than the skewness statistic, you would conclude that the data is symmetric. Okay, so now let's look at the normality test, which is basically that part there. So in this case, we're looking at the Shapiro-Wilk test, not the Kolmogorov test. All right. So in this case, the null hypothesis assumes that the data comes from a population that is normal, whereas the alternative hypothesis assumes that the data comes from a population that is not normal. All right. So the application of the Shapiro-Wilk test indicated that the normality assumption. Now before we fill that in, let's fill in the Shapiro-Wilk. Now this indicates this is a Shapiro-Wilk test with 19 degrees. Sorry, we have 15 degrees of freedom right there. So we have 15 degrees of freedom. The test statistic is 0.839, which gives us a p-value of 0.012. Right. Now, since the significance level is less than 5%, right? This is 1.2%, which is less than 5%. We're assuming that if the population was normally distributed and we took 15 random samples from that population, there is a 1.2% chance of getting a data that looks like the one we got in our sample, which means that this is not because of chance. Most likely the data is not normally distributed, which is why we're getting this data. All right. So in this case, the application of the Shapiro-Wilk test indicated that the normality assumption, since this is less than 5%, is not reasonable for the sodium content, right? So in this case, the normality assumption is not reasonable. Now, the next step is now to figure out which test is more applicable for this particular data set. So to do this, we have to look at the tree, right? So in this case, the tree is out there. So the first question is is to ask whether the sample size is more than 10. We have 15, right? So in this case, it is, right? So yes, our sample size is more than 10. Is our data normal? Unfortunately, it is not. We got a p-value that is less than 5% in our Shapiro-Wilk, so it's not normal. The next question is our sample size more than 30? No, it's not. We only have 15 observations. So in this case, we have no. So in this case, we have to end up using a Wilcox signed rank test. Okay. So for this reason, we're going to look at question number 4 here. Using the guidelines that you have been taught that consider sample size, skewness, and normality, choose and report the appropriate mean test for the following. So click here if you wish to one sample t-test. Click here if you wish to report this Wilcox sign rank test. So we have to use the Wilcox sign rank test here. So I'm going to click here. Now, let's just run the test. All right. So in this case, to run the Wilcox sign rank test, I'm going to go into Analyze, Descriptive. Since this is a non-parametric test, I'm going to click on Non-parametric tests, one sample. Okay. So in this case, I'm going to click on Customize Analysis. The field, make sure sodium is on the test fields, and on the settings I'm going to click on Customize Tests. I'm going to click on Compare Mean with Hypothesized Wilcox sign rank test, and the hypothesized median in this case is 36.6. all right, so I'm going to run the test, and once I run the test, the results look something like this right here. Right, so in this case, the null hypothesis assumes that the median sodium content is equal to 36.6, whereas the median sodium content is not equal to 36.6 for the alternative hypothesis. So the application of the Wilcox sign rank test indicated that the median is, now in this case we have a p-value of 0.020, right? So in this case we have a p-value of 0.020, which is less than 5%. Therefore we reject the null hypothesis. Therefore we're assuming that the median sodium content is not equal to 36.6. So it's either going to be higher or lower, depending on our median that we found in this particular descriptive. So in this case, we have a median that is 36.8, which is higher, right? So in this case, the application of the Wilcox sign rank test indicated that the median actually is significantly higher, right, than 36.6. With a z-statistic, now the z-statistic is going to be given down there. It's the standardized test statistic, which is 2.325 with a sample size of 15, right? So in this case, if your p-value was more than 5%, right, then you would have selected not significantly different too. But since the p-value is less than 5%, your answer is either going to be significantly higher or lower. In this case, since the sample median was 36.8, it is significantly higher than 36.6, right? So in this case, this is the end of the test. So I'm just going to click on Submit and submit all answers, and it is as simple as that. All right. So if you have any questions, you can probably put it on the comments, or maybe just directly message me. That might be faster. All right. Best of luck, guys.